Hi and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 33, a design of chain drive. The learning outcomes of this lecture is to learn the design of chain drives. So consider the worksheet problems given in previous lectures. The design a chain drive to actuate a compressor from 15 kilowatt electric motor running at 1000 rpm. The compression speed being 350 rpm. The minimum center distance is 500 mm. The compressor operates 16 hours per day. The chain tension may be adjusted by shifting the motor on site. So according to these problems, the given data is rated power is 15 kilowatt, N1 is 1000 rpm, N2 is 350 rpm, X is 500 mm. So we have to design according to these given configurations, and we know that velocity ratio VR is equal to N1 upon N2. Here N1 is given 1000 rpm and N2 is given 350 rpm. So we get velocity ratio is 2.86, that is equal to 3. So now we have a velocity ratio, so we can write the number of T on smallest pocket. So for roller chain and velocity ratio 3, we can take the T1, that is the equal to 25, that is number of T on smallest pocket. So T1 we take from this table, and that is equal to 25. Now we have to calculate the T2, that is the number of T on larger sprocket or gear. So T2 is equal to T1 into N1 divided by N2. So T1 we have to take from this table, that is equal to 25. N1 and N2 is given, so we can calculate T2 is equal to 71.5 and that is equal to 72. So now we know the design power. So design power is rated power into service factor Ks. So rated power is given in our problem. So now we have to calculate the service factor, that is Ks. And to calculate the Ks, we first take the value of K1, K2 and K3. So for that we have to use these conditions for the load vector K1. And from this our condition, load vector K1 for the variable load with heavy shock is equal to 1.5. And lubrication factors K2, and for that lubrication factor K2 for the drop lubrications we take is equal to 1. So here K1 taken is 1.5 and K2 taken is 1. Now we have to take the value of service factor K3. So here the condition is given 16 hours per day. So according to these conditions, K3 is taken as 1.25 for the 16 hours per day. So we have a value of K1, K2 and K3. So now we have to place this whole value in service factor equation. So service factor Ks is equal to K1 into K2 into K3, and K1 is 1.5, K2 is 1 and K3 is 1.25. So we get service factor Ks is equal to 1.875. Now we can calculate the design power. So rated power is given, that is 15 kilowatt, and service factor Ks we calculate here, that is equal to 1.875. So design power is 28.125 kilowatt. Now next is power ratings of simple roller chain. So here we can see the tables. Here you can set the speed of smallest pocket or pinion in RPM. Here the pinion RPM is 1000 according to our problems, and Power rating is really 15.65. So according to these conditions, we have to take the chain type is equal to 12B. So 12B, number 12, chain number 12 we have to select with two strands can be used. So now we have a chain type 12B. So according to the 12B, we have to take the characteristics of roller chain according to the standard IS 2403-1991. So here 12B is our chain types, and according to 12B, the P is 19.05 mm, that is the pitch, and roller diameter D is 12.07 mm, and minimum width of roller W is 11.68 mm, and breaking load WB is equal to 59 kilonewton, or you can say 59 into 10 raised to 3 newtons. Now next is, we know that the pitch circle diameter of smaller sprocket or pinion. So pitch circle diameter of smaller sprocket or pinion, that is D1 is equal to P into cosec 180 divided by T1. Here T1 is the number of teeth on pinion and P is the pitch. So if we place the value of pitch is equal to 19.5 and T1 is 25, we get D1 is equal to 152 mm, and if you take in meter, then 0.152 meter. Same this way, pitch circle diameter of larger sprocket or gear, D2 is equal to P cosec in 180 divided by T2. Here T2 is the teeth on larger sprocket or gear, and P is the pitch. So we have to place P is 19.05 and T2 is equal to 72. So we get the diameter D2 is equal to 436 mm, or you can say 0.436 meter. Now each line velocity of smaller sprocket. So V1 is equal to pi V1 into N1 divided by 60. Here we have to place the value of V1 is equal to 0.152 and N1 is 1000 meters. So we get value V1 is equal to 7.96 meter per second. Now load on chain. So load on chain, therefore load on chain is equal to W is equal to rated power divided by each line velocity. As we know, the load on chain W is equal to rated power by each line velocity. So each line velocity we calculate here, that is 7.96, and rated power given in our problems, that is 15 kilowatt. So we can get load on chain W is equal to 1.844 kilonewton or 1.1844 newton. Now next is factor of safety. So factor of safety is WB divided by W. WB is taken 59 into 10 raised to 3 and W is 1844. So we get the factor of safety is 32, and which is higher than the factor of safety tables, and according to factor of safety tables it is 11. So now center distance between sprocket, as we know the center distance between sprocket is 30 into P, and we have a value of P that is 19.05. So center distance between sprocket is equal to 572 mm. Now, in order to accommodate initial step in chain, the value of center of distance is reduced by 2 to 5 mm. Here we reduce by 4 mm. So correct center distance x is equal to 572. That is we calculated in previous slide, and we reduce by 4 mm. So x is equal to 568 mm. Now we know the number of chain links. So number of chain links K is equal to T1 plus T2 by 2 plus 2x by P plus T2 minus T1 by 2 pi raised to whole square into P upon X. So here we have all these values. So if we place the value of T1 is equal to 25, T2 is equal to 72, X is equal to 568, and each is equal to P is equal to 19.05. So we get the number of link K is equal to 110. And now we can calculate the length of chain. So length of chain, we know that L is equal to K into P. Here K is the number of chain links and P is the pitch of chain. So pitch of chain here is 19.05 and K we calculate here, that is 110. So by placing all this value, we get the length of chain is equal to 2096 mm or in meter, 2.096 meter. So this is the design of chain. So in this lectures we learn the how to design of chain according to the given condition. Thank you.